Okay, I've got the circuit built on the PC board, and right now I've removed the 6-volt wire connection to the resistor. Here's the resistor, and I'm going to measure the resistance value, and it comes out to be between 100.4 and 100.5 kiloohms. So that's our value, and that's accurate to whatever the accuracy of the meter is. And in fact, that, I hate to say it so simple, but that is your error in this experiment. The computer is very precise. It has much less error than this, and this is the only measurement you need to get the capacitance of the capacitor. So whatever this error is, figure that out. That is the error in your experiment. So that's the error in the correct value, whatever the label is on the capacitor, which is plus or minus 20%. It's hardly worth even noticing in terms of its error. It's really that crude. But this is the error that you get in this experiment. It's based on the error in your meter. So I'm going to hook this circuit back up by putting this red wire in the same column that resistor lead is in, and we're ready to go. So let's go over to Logger Pro and open it. Go to the File menu, open, go to the Experiments file, and scroll down to Probes and Sensors, and this is a voltage probe. We want to go all the way down to voltage probe, and it's what's called a differential voltage probe. So we click on that, and that brings us to the same screen. That's kind of the default screen. So I've got my probes hooked up. Again, the ground, the black wire is ground, it's to the ground, and the red wire is connected to the capacitor. You want to make sure that the capacitor is the first circuit element next to the ground wire. Don't mix up the location of the resistor and the capacitor. So this is, as it says, a 47 microfarad capacitor, and all we want to do is charge it up. We can watch it being charged by flipping the switch to the red wire, which is the charge, and we can collect data just to watch it charge up. So it's charging up. We want to charge it up to at least 5 volts, and we're there. So we can stop this, get ready to discharge it, which is the curve we want to look at. So we want to hit the collect button and immediately connect to the black wire, which is discharging the capacitor. So this we'll have to edit out, let it go for a while until it gets well below 2 volts or so, then we'll stop it. Okay, so it might be more convenient, especially if you want to plot this, to change your scale to 0 instead of 5 here, and that fills the screen and will fill your plot with the graph. Now, I'm going to do one plot here because all the others are just this accurate. The accuracy is dependent upon that resistor, which we've measured, and that's the only error in this experiment, so we don't have to keep measuring that. We'll just, and also just include one graph, such as this one here, in your lab report and discuss how you analyzed it. So we're going to use the region of interest to measure, to find the fit to an exponential curve. So let's go to Analyze, Curve Fit. There's the curve. Again, you know, to scroll down here to the exponential, the natural exponent, and then try the fit. And you'll see the black line completely overlies the red line, which means it's essentially a perfect fit. So I'm going to hit OK, and let's move this box over, and you see that the correlation coefficient is 1.000. You can see the black line and the red line are on top of each other, There are, between here and the other side of this curve, there are 200 or 300 or 400 data points, and they all fit on that curve beautifully. So here is the value of the exponent, 0.2115, and that's what you use to calculate. We'll take that number and go through that calculation for this particular resistor and capacitor. You probably won't get the same combination because there's a bunch of capacitors and a bunch of resistors to choose from. So anyway, the correlation is virtually perfect, and so this is what you can print out and explain what this means and how accurate it is. 0.2 plus or minus 0.0002, that's 0.1% difference basically. So it's quite accurate. The computer is quite accurate, and the fit is virtually perfect. So this is a no-brainer error analysis lab.